Hey guys, it's Ms. Macaulay, and I'm going to go over and show you the resources for a house to come home to. This was in your notebook on page 112, and the link wouldn't load. Well, I've got it figured out now, so you can watch this video instead. If you don't have the worksheet, you can click on the title of this PDF right here and scroll down to page 4 to see the questions I'm going to go over, but most of you got this in class back in March. So we're on page 4 looking at a house to come home to. Okay. So we're just going to start with some of the overview stuff. Let me zoom in a little bit to make it easier for you to see. Okay, so in this lesson, we're going to explore the various loads a structure can experience in a tsunami and possible design solutions to decrease the likelihood of a structural failure. So basically, what does a tsunami do to your house, and how can you make it so your house doesn't collapse? Here are your objectives. You're going to determine the recommended design elevations based on historic run-ups, so looking at past tsunamis and how far inland and how high up they go. You're also going to identify forces that create loads on a structure in a tsunami, so what kind of force is knocking the building over, and you're going to identify solutions to strengthen structures in tsunamis. So here's the whole picture. You know it's not safe to stay in your house during a tsunami, especially if you're near the coast, but there can be some design solutions that can increase the likelihood that when you come back, there is still a house standing there. In this lesson, you'll examine 7 tsunami load effects and their design solutions. Houses in tsunami-prone areas are also likely to be subject to earthquake loads and possibly wind loads. So how can we strengthen your house to make sure it still is standing? Okay, so here's some new vocabulary words. We have the hydrodynamic force. This is a pushing force caused by the wave on the building, and the drag also caused by the flow, the water flow around the building, and the overturning forces that result. Mitigation, we've talked about that this year. It means the act of making a hazard like tsunamis less severe. We can't get rid of the hazard, but we can make it less severe for you all. Scour, this is erosion around a manufactured structure. Hydrostatic force. It's the pressure on a structure caused by the imbalance of pressure from different water depths. So if there's more water outside than inside, it will crush it. Buoyancy forces. This causes flotation or uplift, so the house can actually be lifted up and carried away. Impulsive force, caused by the leading edge of a surge of water impacting a structure, so that first wave hitting can knock the structure over. Load, it's a force that acts on a structure. If a structure cannot handle this, the structure will fail. It will collapse or crumple. Drag, it's the force that slows an object's movement through a fluid such as air or water, so the water can have drag. And then period, the time it takes for one wavelength, one crest, and one trough to pass a given point. It can be 5 to 16 minutes for a tsunami, and you can get multiple waves coming in. Okay, so first thing is, what should you do if you hear or see a tsunami? We've already talked about this. Or you get the warning signs, an earthquake, you always want to go uphill or inland. Don't get in your car. You want to run uphill, run inland, and get as far away from the coast as possible. So that's what you always do. But what can we do to make sure there's a house to come home to after your evacuation's over? So we're going to go through and we're going to look at what we can do. Okay. So I have the multimedia file on my computer. You can't run it on your computer. So that's why we're going to go through in this video. So let's just take some time. So it goes through and intros this. So let's look at impulsive forces. So look what the problem is here. The leading edge of the water, it causes a surge and it topples the house over. So let's look at a design solution for that. We can elevate the building and use some breakaway walls. That will kind of absorb the force, kind of like a crumple zone on your car. So that's the impulsive force. Let's look at the hydrodynamic force. What's the problem with this? When the water comes, it keeps flowing in and it pushes against the structure even after the leading edge is passed. So the water just keeps coming in. So what can we do? Again, we can raise the house and we can use some lateral bracing to make the building foundation stronger. So you can see both times we want to elevate the house. The first time we could have those breakaway walls to absorb that initial impact. But the second time, we can increase the structural bracing here to be able to withstand those multiple waves. Now, what about debris impacts? Because tsunami is not just water. It scours everything else up, trees, logs. It's going to crush your house. What can we do? Lift it up. But then this time, use a protective barrier. So we could have some pine trees. We can have a wall here to help keep some of those things from hitting your house. Now, the hydrostatic force, this is the one where the water will be there'll be more water outside the building, and it will crumple your house essentially. So what can we do? Elevate the building, breakaway walls again, and also make deep anchors into the bedrock. Okay, flooding. Well, that one's pretty straightforward. What can we do? What do you think? Elevate the house, okay? Or don't build right near the coast. Choose a higher elevation up here maybe, and then use concrete and steel for parts of the building subjected to flooding, so they're not going to get all rotten. Okay, buoyancy. This one is that the house is going to float. What can we do? I bet you guessed it. We can elevate the building, and we can create a better anchor and use materials that are more dense and resistant to uplift. So choose steel instead of lumber. And then this last one, foundation scour. So when the tsunami comes in and then it goes back out, it's going to erode away at the pilings here, and then that's going to cause some structural problems. What can we do? Design for scouring. So use deeper foundation pilings. So we've gone through and we've seen all of these. So what is the most common solution? What are we always going to do? We want to elevate the house. So build up, or build inland, so get away from the coast. So which of the following design solutions strengthens the home capability to withstand hydrodynamics? So let's go back. We want to find those hydrodynamic forces. So it continues pushing against the structure even after the leading edge has passed. What do we want to do? Use beams, use lateral bracing, elevate. So beams, bracing, elevate. Yeah, lateral bracing, was that correct? Yes. Use a horizontal beam added to the foundation that is parallel to the incoming perpendicular. So let's see. It's going to be A and either B or C, so we got to figure out which one it is here. Let's look at the direction of those. So show the design solution. Which way do those braces look? Are they perpendicular or parallel? To me, it looks like they're parallel to that incoming one. So we're going to say A and B, and we'll go back and double check that. So that's your best answer. Okay, which of the following design solutions combats hydrostatic forces by providing adequate openings to allow water to reach equal heights inside and outside the building? So hydrostatic, let's go back here. So let's look at the design solution. Breakaway walls, anchor the building. Okay. Breakaway walls, that's the main thing. Adequate openings inside of the house. And breakaway walls limit which four forces? Well, we see one right here. It limits the hydrostatic. So what else can it limit? Let's see here. Can it limit the impulsive? Yep. So use breakaway walls. That'll be the impulsive force, that first wave. Let's see. Hydrostatic. How about the hydrodynamic? Will breakaway walls help with that? Doesn't recommend it, but let's keep looking. So what about debris impact? Doesn't say. How about flooding? Buoyancy, maybe? Foundation score. Okay. So it only lists 2 here. But if we go through and think about it critically, we can probably find some more that it would also apply to. So we're going to check the answer key here. For 7, it also lists hydrostatic, hydrodynamic, and buoyancy. So we can add that to that. So hydrostatic, hydrodynamic, and buoyancy. Okay, let's see how else we did. So we said breakaway walls was the best answer for 6. Let's see if they agree. Yep. Now number 5, E, A, and C. Let's see how we did there. Well, we thought it was A and B on number 5, but it says it's actually... Oh, come on here. It says actually E, A, and C. So this was perpendicular. We must not have interpreted that picture. Let's go back and look at that one. Hydrodynamic. Let's see if we can tell if it's perpendicular. Use beams and bracing that reinforce. Now, I thought it was parallel, but maybe with the simulation there's perpendicular. But we did our best. We elevated the building, and now you've seen how we can improve your house's survivability from a tsunami. Thanks for watching, guys. I'll see you next time. Bye.